So, we have been discussing about analyzing circuits where ideal op amps will be present with negative feedbacks. And and we have seen that if you have signals, then you can add them using an op amp. Output signals will be sum of these two signals as well as amplification. Similarly, you can subtract two signals that we have discussed in the previous circuit. Another interesting circuit is this one, suppose you have an op amp, ideal op amp, and these are the two things where you connect a resistance R here, connect this is your input signal V1, this mind you is negative, this is plus, and here what you do, you connect a capacitor. This will be your output signals and this is grounded. Mind you, this is your V A and this is your V B. Looking at this circuit, I will say V B is equal to 0, potential of V B, this is equal to 0, and if this is 0, V A cannot but be 0. It has to be also 0. Why? Because voltage drop between these 2 points V A minus V B is equal to 0 for ideal op amp. There is a negative feedback through a passive element C. So, output voltage will be finite and we want to find out the relationship between output and input voltage. So, what you have to do? Same procedure, you have to write down KCL at this point, KCL at this point will be how much? KCL will be the current going in here, this is V naught, is not. So, how much is the current here going? This current is V 1 minus V A by R, which is same as V 1 by R, because V A is 0 and what is the current going there? Same current has to go, is not? Same current has to go. So, current in this branch is, if I say this current is I, because ideal op amp does not take any current practically. So, this current goes there. So, this is I, this is also I. If this current is I, then voltage across the capacitor, you know, with this is plus, this is minus. What is the voltage across the capacitor? Here you should be careful. Voltage across the capacitor is V A minus V naught, V A minus V naught, and that should be equal to, we have learned so much about capacitors. So, this must be equal to I dt. This is how it will go, and I must be consistent, this is plus minus. So, I going into the plus that is to be integrated. If you integrate, you get the potential of this point with respect to this, but V A is 0, therefore, or V naught is equal to minus 1 over C into I dt, but I is V 1 by R. So, this will become minus 1 over R C into this one, I is V 1 by R, I am putting that. So, it will be V 1 dt. Therefore, output voltage is what? 1 by R C is constant. So, it will whatever input signal it gets here, it will simply integrate that and will return you at the output. So, it is called integrating circuit, integrating circuit, very popular circuit used in op amp. It will of course, invert the input signal. After integrating, it will scale it up or down depending upon 1 by R C. So, there will be an amplification factor as well as inversion of this input signal, we can easily see. Similarly, you see another circuit just similar to this. Suppose somebody connects and a capacitor here minus plus, this point is grounded and he connects a resistance there, that is he reverses these two elements. This is output voltage. Is there exists a negative feedback here? Yes, this is a passive element and this is C, this is V 1, and henceforth I am not going to write down V A here, because I know this is V B which is 0, V A should be equal to V B. Therefore, V B is 0 means this potential is also 0 volt. I will straight away write down this equation. So, this current I has to be same as this current, because no current is drawn by the ideal op amp. So, I, what is the value of this current? It will be potential of this point with respect to this, that is V 1 by C, I is equal to 1 by C V dt, is not? This is the rule for the capacitor. If you, this is I, this is the voltage, this V. So, that is the rule. So, 1 by C, what is the voltage of this point with respect to this V 1, is not? So, or you can say okay, let me write 1 by C V 1 dt, you integrate it, this will be the current and this current is same as this current. So, this current is how much? This current is what potential of this point minus potential of this point divided by R, that is 0 minus V naught by R. Or I will say you get this output voltage as V naught is equal to minus, some mistake is there, C, this should be C 1 by C I dt, I am so sorry, this equation Q by C, no? See, you should be careful. Q by C is the, let me write like this, let me write like a much more simpler way. So, just one second, I will delete it. This one was correct. No? Now, here what I will do, this current relationship, you see this I in this case, this problem, I is equal to also C dV dt. So, I will write C dV 1 dt, in one stroke I will do. This current is voltage across the capacitor, I is equal to C dV dt. That information I use, and I am consistent. This is the direction of the current, this is the potential of this point with respect to this. So, C dV dt, this is the value of I, and once you get that, this I, this same I flows here. Therefore, I will say in this branch this current is 0 minus V naught divided by R has to be also this current, that is C dV1 dt, or I will say V naught is equal to minus R C dV1 dt, is not? This will be this. So, this circuit will behave like a differentiator, that is, you give an input signal V1, at the output the voltage will be proportional to the differentiation of this signal. So, this can be termed as a differentiator. So, you are differentiating a signal without doing mathematics. Realizing a circuit like this, you can always say output voltage will be the differentiation of the input signal. Like that, there are several problems you can do it. One very quickly I will do one small problem. In fact, I will solve two more problems, so that you understand. I have taken it from a book, exercise problem to be done by the students. I will name the books in the next class. Suppose we have a voltage here 0.4 volt. Let us see how quickly we can do it. Here is a circuit given. This is drawn like this, plus minus, and here is a resistance here, which is say 3 K, and there is a resistance there, it is 2 K, and at the output you have another resistance, say some value is there at the output. We will see this value I have forgotten. Now, in this circuit I have been asked to calculate what is V naught, I have to calculate. Okay. Now, how to calculate V naught in this circuit, and this is suppose some I naught will be flowing in the resistance connected. Now, if this is the output signal, is there a negative feedback? Yes. See, this time it has been drawn like this, but you should not be under the impression that it is a positive feedback. It is a negative feedback. To the negative inverting terminal, a portion of the output signal is fed. So, under this condition, you know, this current drawn by the op amp will be 0. So, this potential is 0.4 volt. This is the ground. With respect to this, I am measuring 0.4 volt. There will be no current here. Therefore, this current, that is current in this path, will be simply 2 and 3 K in series, is not 2 and 3 K ohm in 8 K. Let us call this is given to be 8 K actually. So, this current will be I, this current will be V naught divided by 8 plus 2 K is equal to V naught by 10. Then what will be the potential of this point? Potential, this is the point B, V B will be voltage drop across 8 K. So, 8 into V naught by 10, which is equal to 4 V naught by 5, so much volts. Now, it is an op amp, ideal op amp with negative feedback. Therefore, potential of this point and this point must be same. Now, what is the potential of this point, that is point A? It has been conditioned by this external source 0.4 volt. So, I will say that V A has to be equal to V B, and V A, as you can see, it is 0.4 volt. So, I will say V B, which is equal to 4 V naught by 5 into this one V B, and that is equal to 0.4 volt. So, V naught will be equal to 0.5 volt. 0.5 volt. So, at the output you will get 0.5 volt, and if you have terminated this output by some resistance, say 1 k here, this value, then I will say this I naught will be 0.5 divided by 1 k, this is volts. So, this will be 0.5 milliampere. How first you can solve it, you must understand, that is ideal op amp in any circuit with a negative feedback. This is the crucial thing, V A and V B should be equal under those conditions, and you can solve a circuit. Let us take another circuit which is slightly bigger than this, but let us see with 2 op amps. Another example. The circuit goes like this. Here is a 1 milliampere current source, okay, across which there is a 4 k connected, and this one is fed to an op amp which is drawn like this, with this is plus. I think I should, this one is connected here to the plus terminal, like this 4 k, and at this output, let me first draw the circuit. There is a 3 k connected, and this is there plus, and here is a minus, there must be negative feedback. Let us see where from the negative feedback is taken. Now, at the output of this first op amp 3 k, now this one, only one op amp here, this one is connected across a 1 k and 3 k, 2 k in series, and this potential is fed back here like this. This is the circuit. What you have to calculate is the output voltage V naught, you have to calculate. For example, to begin with, they have asked you to calculate some other things also, calculate the current here, this, that. Now, first thing we should check that okay, there is a negative feedback, because a portion of the output is drawn here, it is an ideal op amp circuit, things like that. Now, how to solve this circuit? So, this is V naught. Okay. Can there be any current here? Yes, I do not know, because this is not this input terminals. But what I know is this output voltage, whatever it is, this current here it is 0, no current will be inputted. Therefore, there will be no branch of current at this point. Therefore, the current in this branch will be just series thing, that is this current will be V naught by 3, if V is in volts, this is kilo ohm, so much milliampere is flowing here, and the potential of this point then will be this current into 2, and this is the potential that is equal to V A. So, V A I have been able to calculate, V A is known, is not, that will be V A. Now, what I am telling, if this is V A, the V B has to be same as V A, and this voltage here. So, V A I have got is equal to 2/3 into V naught. So, this potential is also 2/3 into V naught, that is the thing. Got the point? This is the voltage which will exist here. What will be the current in this branch? Op amp does not draw any current. So, this current is 0. Therefore, this 1 milliampere will circulate here, and what will be the voltage between these 2 points? Potential between these 2 points will be then 4 volt, 4 k into 1 milliampere. So, this voltage is known. So, 2/3 of V naught must be equal to 4 volt, or V naught will be then equal to 12 by 2 is equal to 6 volt. So, this output voltage, the answer will be 6 volt. Then whatever things you have been asked to calculate, you can calculate. What will be the current in this branch? Current in this branch will be 6 by 3, 2 milliampere will flow here, and so on. Therefore, you see, no matter how complex this circuit looks like, you can always look for whether negative feedback exists and the op amp is ideal. Then this is the crucial thing, V A and V B, they should be then equal, and this current drawn by the op amp is to be 0. That is the clause. It is much simpler than what we have solved earlier. Let us solve another problem, another example. Examples. This circuit is having more than one op amps. Suppose you have a circuit like this. Let me draw quickly. So, this is some 10 k, this is some 50 k, here is a voltage source plus minus 6 millivolt, and here is a connection which goes like this. This connection is very popular, and this is minus, this is plus. Now, this op amp is output of this is fed to another op amp, whose inverting and non-inverting terminals are connected in this way. Okay. And here is this a negative feedback exists? Yes, here for this also 30K, some values are given. And then you have a third op amp, 20K has been connected, and this op amp looks like this, minus plus, and this is a 40K resistance, and this output voltage is here for this whole thing. This is the input signal, output voltage, and this one is connected here by 8K impedance. Hopefully, I have drawn the circuit correctly. Now, for this problem to do how to proceed, first of all this current here will be, here is a negative feedback for this op amp. So, this current is 0. If this current is 0, there is no voltage drop here. So, for this transformer, the non-inverting terminal voltage, that is VB1 is equal to 6 millivolt. It will be like this. If it is 6 millivolt, ideal op amp, negative feedback, this will be also 6 millivolt. So, here this voltage is 6 millivolt, has to be, no resistance here, same voltage 6 millivolt. Now, for this op amp, let this voltage be called V02, second op amp. This is V01 of the output of the first op amp. Now, this potential is 0, there is a negative feedback. So, 0, so this voltage must be 0 volt, that is VA2 has to be 0 volt here, because this is 0, then op amp does not carry any current, it will be 0 volt. And then this voltage we have to calculate. So, what do I do is this, for this op amp I will write down the KCL equation at this point. Okay. So, KCL if you write here, how I am going to write it? It will be this current 6 millivolt, mind you. So, take care of that. See, the potential of this is 6 millivolt. So, 6 into 10 to the minus 3, keep the voltage in volt, minus 0 volt divided by 10 is the current coming in. Here this current is 0. So, this must be same as this current, which has to be equal to 0 minus V02 by 30K. Is not? This will be thing. Therefore, I can calculate V02 to be, this can be 30K. So, K you forget, current we are measuring in milliampere and so on. So, if you calculate V02, it will be minus 3 into V01, that is minus 18 volt, minus 18 millivolt, that 10 to the millivolt suppose voltages are. So, it will be V naught 2 is known. What is V naught 2? Potential of this point is known. Then if I know the potential of this point and if this is an ideal op amp, so the current in this the potential, if this op amp does not take any current, this V naught 2 will appear here minus 18 volt, and there will be no current here. So, current in this path will be V naught by 48, and potential of this point will be V naught, potential of this point will be this one, will be V naught by 48 into 48, is not, and that is 5 V by 6, so much volts. So, I have been able to calculate this potential. So, this potential, there will be no drop here, because of that this potential and this potential are same and this current is 0. With that condition, what will be the potential of this point? It is already calculated to be V naught 2 is this potential, but from this I know the potential of this point has to be 5 V naught by 6 volt, is not. Therefore, I can proceed to calculate the output voltage as, how do I calculate the output voltage? This current is 0 and this potential V naught 2 is minus 18 volt. So, this current, what will be the expression of this current? Minus 18 millivolt minus potential of this point, this current I am calculating, divided by 20 k, and that must be equal to 0. Therefore, I can say 5 V naught by 6, this 20 does not matter, is equal to minus 18, and your V naught will be equal to minus 18 into 6 by 5, that is minus 21.6 volt millivolt. Anyway, roughly this will be close to 18 volt, slightly less than that, 18 into 6 by 5. So, this is the answer. So, we started with this and applied the same rule for all the op amps. Here it is no feedback. So, 6 millivolt, it should not draw any current. Therefore, there will be no drop in this 50 k. So, same voltage appears here, and there will be, if this is 6 millivolt, this point potential is also 6 millivolt, it comes here, then 6 millivolt, and look at this op amp, this is at ground potential, and so it has to be at 0 potential. So, many things are known. So, the current in this one 6 minus 0 by 10 k, it does not draw any current, that current will be same as this current, which will be 0 minus V naught 2 by 30. It will be this current, we have calculated that. So, from that I got the value of V naught 2 output, and once I get V naught 2 here, look at this third op amp, it is V naught, this is, there will be no current. So, V naught by 48 into 40, that will decide this potential, that potential you bring it here, but this op amp should not draw any current. If that be the case, then I can easily calculate the output voltage. Therefore, these are some of the examples. So, we have discussed some ideal using ideal op amp circuit, what can be done. My next class will be the last lecture class, where one more circuit I will discuss about op amp, and it will be a concluding lecture class where this whatever I have tried to cover, I will discuss briefly about that, and you please prepare well for the examinations, covering the courses, but do not just remember formulas, try to concentrate on the basics, and I hope all of you will do very best in the exams. So, next class will be the concluding lectures. Thank you so much.